All right, well, welcome everyone. So I'm Greg Coralla. I'm a business development manager with Amazon Web Services. Joining me today is Mangeshi Doble from our solution architects. She's going to be doing the demonstration. So a little bit about myself. So I've been with AWS about 2.5 years, primarily focused on QuickSight, Redshift, and our relational database service. My background is mostly from Oracle and Intel. So today's session, just curious before we get started, how many folks are currently in the QuickSight preview? So fair numbers. And how many are completely new to QuickSight? Okay, so vast majority. So for those of you in the preview, some of the material that I'm going to go through in the presentation might be a little bit repetitive, but happy to take questions afterwards as well. So I think we got a few slides I'm going to go through just to kind of set the context for QuickSight, what it is, what use cases. I'll talk a little about the architecture, and then I'll try to go quickly through the slides so that we can devote a good amount of time to the demonstration that Mangeshi has prepared and time for questions as well. So I think in terms of where QuickSight fits in context of Amazon Web Services, I think it's important to understand the way we think about developing new products at AWS and new services. And of course, it's based on the feedback from our existing customers. So we have a wide and growing portfolio of customers that currently use a wide selection of our services within AWS. And it's really their feedback that helps us drive based on their use cases and areas that we can help them with new feature launches, new service launches, and of course, always looking towards cost optimization as well. So this is things about our innovation and how customer feedback really helps drive that innovation cycle. If you think about the history, so of course, most people think of cloud computing and maybe AWS in terms of compute and storage and networking. And of course, with these primitives, you can have a Windows or Linux instance and install your software application of choice, whether it's a database or application or even a BI tool. But what we heard over time from customers is that the complexity of maintaining particularly databases becomes burdensome on application teams. And so if you think about this life cycle of innovation at AWS, we've sort of started thinking about database as a service. And when we think about adopting cloud patterns, we don't want to think about a database generically, but understand, is this really relational? Is it non-relational? Is it primarily a cache problem we're trying to solve? Is it Hadoop infrastructure that I'm trying to maintain and run? Or is it something focused more on streaming or relational databases? And so for each of these different use cases, we've essentially moved beyond just compute and storage and have managed services where we can take your workload and match it to the right data pattern in terms of an engine, and then not just presenting you with a Windows or Linux installation, but actually taking care of the database, meaning we do the installation, configuration, the patching, the backups, the high availability planning. All of these things are super critical from a database administrator perspective, but oftentimes we refer to them as undifferentiated effort, meaning that we want to have our DBA teams to focus on the application and your end user and your customer experience and not the infrastructure, because we now provide that as part of our managed service, and then understand different workloads require different types of engines in terms of really driving the value out of them. So if you kind of look at that a little bit more from a visual perspective, we oftentimes think about ways to collect data, ways to store it, and then ways to analyze it. And if you've been working with Amazon Web Services for a while, most of these names should be fairly familiar. So there's many ways to be able to have physical connection into an AWS, whether it's a hybrid architecture or even transition states where I might need to move from my existing infrastructure into the AWS cloud. And so things like virtual private cloud and direct connect, and then ways to be able to bulk load data either through Snowball. But then increasingly we see use cases where streaming analytics becomes a core requirement. And this is sort of the Internet of Things type applications where imagine your mobile device or a game running on a mobile device and you want to collect data at scale. And so the streaming use case, we have a service called Kinesis. But whether the individual data point is a stream, a file, or an object, we essentially want to land it into the appropriate storage engine. So if it's a transaction, we have a relational database service. If you're looking for very high throughput reads and writes, we have a NoSQL store called DynamoDB. And then, of course, for data warehousing type applications, we have a service called Amazon Redshift, which is essentially a cloud-powered data warehousing for applications that require analytics. And then if you kind of build this out, the piece that customers have asked for is, hey, you've got essentially ways to collect data, store it, and analyze it, whether it's structured or unstructured. What would be great is if you could then tie it together in terms of a visualization layer. And we want to think a little bit, uniquely about this visualization layer and solve problems not just for relational, but then also for files, non-relational, as well as API data sources. And this really is the use case that QuickSight has been designed for. So if you look at the challenges in terms of traditional business intelligence, I mean, some of these questions I think can be fairly straightforward, but more and more we think about BI systems or just visualization layers, and how do we adapt visualizations to new patterns where volume, variety, velocity are super important, and then what are new ways that we can speed the performance. And I think that these kind of questions oftentimes get surfaced to us in terms of problems that customers would like us to help them solve. And so if my background, I kind of mentioned I spent some time at Intel as well as Oracle, and I was actually part of Oracle BI team for a number of years. And in my experience, anyways, I think a lot of these bullet points on this slide resonate with projects I worked on, where in a traditional BI environment, you have to, of course, acquire the software, commit to probably a perpetual license of some sort, install it, configure it, maintain it. But then, of course, once the physical infrastructure is set up for the BI system, I then need to go through sometimes a long process of establishing the metadata layer. So this could be, if you're come from business objects, this might be creating the universe, or essentially the translation layer between the technical data structures and the way the business views the data set themselves. And this metadata layer oftentimes becomes the translation layer between those two environments, technical and business. And the maintenance of that has, different organizations kind of look at it in terms of different spectrums, but oftentimes it could take a number of months where we have to go through an onerous process of maintaining those definitions and set of administrators. So what oftentimes happens is the business might have a question, but it might take, a few weeks, a few months in some cases to actually prepare the environment just to be able to ask that question. So this is really where the cost and complexity of traditional BI systems have really inhibited the breadth and depth of analytics that our customers are able to discern. So there's just a different way of expanding upon this. But of course, moving beyond just relational sources, how do I take into account the data structures that are most common in customer environments today? And this could be non-relational. So if it's DynamoDB or Cassandra or Mongo, if it's a stream of data coming from Kinesis or Kafka, if it's a file just sitting on a file system like S3, how do I incorporate these new data sources into my overall reporting infrastructure without having to be forced to consolidate all of that into a single data store? So the idea of QuickSight, of course, is to give you the freedom to get the value out of the data you already have. So certainly, from best practices perspective, lots of different thoughts. Hey, should I consolidate all my information into a data warehouse, whether it runs in the cloud or on-premise? Perhaps based on your use case, that still makes sense. But how can we distribute data and report on data where it resides, but still offer a way to have super fast performance in terms of query response time, regardless of the data format? So of course, this is what QuickSight is targeted at. We announced the preview back at reInvent last October. And I think a number of folks in this room are already part of the preview, and we'll talk about features and capabilities. But just keep in mind as we go through the demonstration and you actually get to see some of the functionality, that definitely is still a work in progress. And so we're really proud of the work the engineering team has done. But we continue to add fit and finish and polish, and we're still anticipating general availability later on this year. So the mission statement for our team and QuickSight is essentially a cloud-powered BI service at roughly 1/10 the cost of traditional BI systems. And I'll kind of break down each of these statements in terms of what do we mean by fast, what's a managed service, and and some insight into pricing as we go through today's session. And the tagline, right, it can be as low as $9 per user per month. And this oftentimes is what really attracts customers to understanding, if you compare that to your on-premise BI tool, that it can really be, the tagline might be, well, it's low cost, but really what this means to me is that there's all kind of analysts in our organizations where they have questions, but we haven't been able to justify the licensing costs to enable them with the power and insights like a system like QuickSight could offer. And so we really think that this will open up insight into your data, not just the variety of data sources, but also just the number of people that can now start using a system, because the price point makes sense for the business to enable that functionality. And so beyond just thinking about the cost, the other important thing is how quickly can analysts actually discover a data source and then start reporting off of it. So I talked about my experience. I worked with a large retailer in my experience with BI systems in the past, and what they told me was it took them about 6 months between a question and when they're able to identify data sources, feed the data sources into their data warehouse, expose that data source through their metadata layer, and then provide a report to their end user. So it actually was 6 months, and it just was too burdensome, right? And so line of business basically found a way to get around it, right? And all kind of tools kind of proliferated where, hey, just give us access to the data. And then, of course, that meant, okay, we got to give them a copy of the data. Then all of a sudden, our data store starts exploding, and security requirements are kind of a pain to deal with. So the first idea of QuickSight is that beyond just the performance and cost is we want to make it very easy for, of course, the appropriately empowered in terms of access control and security and audit compliance, but for the right authorization to be able to quickly discover a data source, do some transformations of that data, or renaming of it if it's appropriate, but then start reporting off of it and make that process as fast as possible, and not have the requirement of a client tool on a desktop, but do everything through the web browser or through a mobile device like a tablet or phone. And so if you think about the basic architecture of QuickSight, I'll kind of build this slide out a little bit and talk to it. I mean, we'll kind of go through some more details, but the first thing is to think about the ways that our analysts want to consume data. So we want to have equal interfaces, whether it's a browser or if it's a mobile device. So if it's a tablet, even a phone, given the appropriate form factors, but essentially, provide the information in the format that the analysts would like to see it, and given the importance of mobile, really have a mobile-first strategy with QuickSight as well. And then, of course, from an infrastructure perspective, we'll go through some more details, but one of the painful points of traditional BI systems is, hey, how do I configure and install the driver, right? So with data prep and connectors, all the data sources that QuickSight supports are natively installed as part of the service itself, right? So I don't have to configure an ODBC driver to connect to my Oracle database, right? I can just have the Oracle database connector there and just, of course, enter the connect information in, but not have to install the software for that. And then through data prep, I want to be able to provide this translation layer between the technical details of the data source and the way the business sees it. And, of course, overlay a security model for authorization as well. And then all this kind of leads to this collection of metadata, which really is a description of the data itself, right? So where does the data source reside at? What renaming have I done? What calculations have I added? Which, we'll call them metrics have I created? And essentially have a single repository for all that information. And then I'll dive deep in a slide or two going forward, but then we want to think about how we can enable fast, and some in this case, super fast performance for those queries. So in traditional BI tools, right, I need to really think about tuning of my data warehouse or my database, because the more I can tune the database, the better, the faster queries will respond, which means that I'll get reports rendered faster. So with QuickSight, in addition to the user interface and the mobile experience, we also have a caching layer we call Spice, which is super fast, parallel, in-memory calculation engine, right? So as we say, add some spice to your data, all good things will happen, right? And so I'll talk more in detail here in a second, but essentially think about an in-memory columnar database as a managed service. So you just tell us the amount of data and the number of users that can access it, and we provision all the infrastructure behind the scenes for you. So it's a horizontally scalable in-memory columnar data store. And then the other thing is think about this idea of how long it takes for an analyst to see a data source and creating reporting. We want to think about suggestions. And so think about recommendations on Amazon.com retail side. And so based upon the data source you're looking at, hey, what's the most likely visualization of that data, or what else have other analysts in your similar position, what have they created based upon this data? So can we offer these suggestions to kind of get over that first step of data discovery? And on the bottom, from a data sources perspective, whether it's on-premise or in AWS, and to think about relational, non-relational, file, and API data sources. So, of course, relational like Redshift or SQL Server or MySQL. Non-relational, things like DynamoDB, Cassandra, Mongo. API data sources can be things like Salesforce, Marketo. But then just something as simple as a file sitting on S3, right? Can I ingest that file into a caching layer like Spice and then start reporting off of it without having to go through transformations to put it into a relational data store? So then the question comes up from a pattern perspective. Okay, I've got multiple data sources. Some of it is on-premise, some of it's in AWS. Might have 4 or 5 different data stores. How do I combine that together? And the first thing to think about is the concept of data lakes, right? Which probably today is a little bit more of a marketing term than I would prefer to use in a technical talk. But thinking about where do I consolidate the data, right? And more customers think about S3 really as that layer of data consolidation, because although S3 provides 11 nines of availability, you only pay for 1 copy of the data, right? So you're not having to pay the HDFS tax of 3x replication, right? Or if the data is fundamentally structured, to think about Redshift as a consolidation point for this data, and then apply security or bucket policies on top of that data in terms of access controls. This is just one example of a way that I can consolidate data at the S3 or file system or the database level. So the other way to then think about this is that I've got all these different data sets. I can combine it into S3 or to Redshift, and then overlay the security policies on top of that to then, of course, load the data into the calculation engine or caching layer called Spice to make available through the user interface. And this is just one suggestion. I think as customers start using QuickSight and Spice in more broad use cases, we'll kind of see a hybrid of this. Of course, customers say, well, that's great. I don't want to consolidate the data. I just want to load the data into the Spice engine and do the joining at that level. But from a performance perspective, access control perspective, this might be one way that customers will start with in terms of combining multiple data sets. And so if I think about what the innovation that QuickSight really drives, of course, we think we hit on most of these bullet points. We'll just kind of drive into a little bit of the Spice layer. So we talked about this super fast parallel in-memory calculation engine. And what does it actually do? And so first is, regardless of the data source, so certainly from a QuickSight perspective, if I have a relational database, let's say Redshift, and I just want to query the database directly, you can always just pass the query off to the data source, the SQL query off the data source, and we'll get the results set back and render the report like most traditional BI tools use. But then let's also think about, okay, well, if 10% of my data is accessed 95% of the time, maybe it makes sense to take that 10% of the data from the relational source, put it into an in-memory columnar data store, and then have super fast, or you might say millisecond type response time excuse me, from there. But of course, if it's not a relational source, if it's a file on S3, how do I push a query down to a file system? And so the ability to expand beyond just relational sources, I think, is going to be a really interesting use case for QuickSight. And then in the Hadoop ecosystem, whether I'm using Presto or Hive or the whole family from the Hadoop side, how can I visualize data fast and efficiently from there as well? And so Spice allows you to identify a data source. So if it's a RDS, Relational Database Service, or Redshift, we will automatically detect if QuickSight is running in that account that the RDS or Redshift instance is in, will automatically detect those, and you won't have to configure any connection to that. Or you can simply enter the connect information in to be able to physically connect to that data source. And then we automatically detect data types and schemas to be able to pre-join data if it's relational, right? Of course, you can still, as administrators, override the joins. You can define your own joins. You can copy and paste your own SQL statements in. With this ability to go from, hey, there's a file on S3 to a visualization, right? We want that to be very quick. We want that to be relatively easy. And of course, with the appropriate controls, empower users to actually do this without administrator intervention unless advanced functions need to be applied. And so with Spice Engine, of course, I mentioned it's a columnar database, so it still takes advantage of columnar compressions, and it still takes advantage of encryption, access control, where we have a SQL-like interface. So if you look back on my architecture slide, you might have noticed off to the right, there's a number of our BI partners, or business intelligence partners like Qlik and like Tibco. And so the idea is that we're really proud about the user interface we've built with QuickSight, but we realize that not all customers will, and all use cases will align to the visualizations we have. Or our customers might want to build their own visualization in something like D3. And so we still want to take advantage of this horizontally scalable in-memory calculation engine called Spice, but then make a SQL interface to it available so that other BI tools or other projects can actually take advantage of the performance and the collection of data that the Spice engine can bring. And the other point is, a feature that we'll see in the demonstration a little bit is this idea of autograph. So once we have the data structures in Spice, when you for instance, select category, from a sales perspective, let's say I have a collection of items grouped into categories. If I just say category, I don't want to have to then think about, well, what's the appropriate visualization for this, and what's on the x-axis or y-axis? Of course, you could always modify that, but just from that first experience, we want to be able to infer cardinality of the data. We want to look at the data types, and give that analyst, hey, most likely this is going to be the first visualization, or the visualization that makes the most sense based on this data types. And so we call this autograph, which is just that starting point, right? To get over that hump of data exploration. And of course, you can always go back in and edit the chart, and we'll talk about the visualizations that we have, and the visualizations potentially that we will add based on customer demand. But we think autograph will really help overcome some of the burden of BI systems in the kind of exploration of data. And then from a mobile experience, just given the prevalence of mobile in our everyday lives, of course, we want to have mobile as a first-class visualization that's built from the very beginning in QuickSight. So whether it's a tablet, Android, or iOS, even for phone, for the right form factors, to be able to have a full user and administrative perspective from the mobile device, I think will be very important. And then not charge extra for it, right? So mobile comes with QuickSight. There's no breakout for, oh, you got to pay extra for the mobile. It just comes with the base product itself. And of course, to be able to tell a story with your data. So it's great that I have a dashboard or report, but think about the day in the life of an analyst. And I think Wangeshi will kind of walk through this in the demo in a second, where you want to do an exploration of the data. So an analyst is going to say, okay, I got step 1, 2, 3. I'd like to be able to document those 3 steps, save it as an independent item, and then share each of those steps with the appropriate comments and ability to annotate on top of it, and share my end-to-end analysis with other sets of users, such that the data analyst might be the person that goes through, hey, I've got a high-level problem, let's drill down to detail, saves that full end-to-end process as a single object that can either be embedded in another application or can be shared through the QuickSight user interface with the appropriate controls. And that object that they've created is not just static images, it's actually an interactive charts and graphs. But you're simply providing that set of steps to walk through, and we call this a storyboard. So having said that, kind of gives you the highlights. Hopefully, for those of you who have seen QuickSight, wasn't too much repetitive, but I think, really what's powerful is to kind of see this in action. So Wangeshi has created a, I think, fairly compelling demonstration for us to kind of tie this together, and then we'll wrap up with 1 or 2 slides at the end. I'm happy to take your questions. Oh, sorry.
That's okay.
I think to go back one.
Okay. Okay, thank you, Greg. So this is the demo portion, and I wanted to point out that for this demo, we actually focused on financial data. There's a lot of data out there, but in this case, we wanted to have fun with financial data. So have you ever wondered if there's actually a correlation between the stock price and the number of tweets related to a company? So I'm going to give you a QuickSight demo or tour, and at the same time, we'll try and answer that question. But before we do that tour, let me give you an overview of what comprises the demo. So the first thing I did was ingest or download publicly available financial data, stock market data from Yahoo. And then the next thing that I did, I thought I was starting the demo now. So the next thing I did was to actually transform that data into a format that's compatible with Redshift. And I staged that data in an Amazon S3 bucket, and then I applied a Redshift copy command to move that data into Redshift. And then I used Kinesis Firehose to basically ingest tweets. And what I did, I collected tweets just over a short period of time. This was like 5 days at the beginning of April. And then I also filtered those tweets based on the company names or the companies whose stocks I had downloaded from Yahoo, which is essentially all the stocks which are traded on NASDAQ and New York Stock Exchange. So the cool thing with Kinesis Firehose is that it integrates with Redshift. But the way it works behind the scenes is that it's going to temporarily store your files in the Amazon S3 bucket that you specify, and then it's going to apply a Redshift copy command behind the scenes. And then what I did after that was basically do my analysis and visualization with QuickSight. Okay, so I'm going to give you a tour of a recorded demo. So once you sign into QuickSight, what happens is that the start page defaults to the all analysis page. And on this page, as you can see, I have all the analysis that I've been working on. And it also shows some of the times when I updated those. And then if you are getting started with QuickSight, you have the option to actually view some demos. And then you also have the option from this page to create either a new analysis or manage your data sources. So when you click on Manage Your Data, what happens is that QuickSight is going to default by showing you all the data sets that are available to you. And a data set is essentially a set of data that you've created based on a specific data source, and that's what you really want to work with. At the same time, QuickSight tells you how much spice is available to you, and this value is going to change when we go into GA. So when we click on the new datasets page, that's where you have the option of creating a new data set, either from an existing data source. And as you can see, I have several existing data sources that I've created in the past. Or you have the option of creating a data set from a new data source. And in this case, like Greg mentioned, you can upload a file from your desktop, or QuickSight, you can connect to a data store that's already integrated with QuickSight. And at GA, again, this list is bound to change. And because my data is stored in Redshift in this case, like you saw in the overview, QuickSight actually auto-discovers my Redshift cluster that's already running. So I can select that data store. And then from there, I can give that data source a new name so that I can identify it, provide valid credentials, and then from there, I can connect to Redshift. I then select a schema that I'm interested in, and from there, I can select a table that I want to work with. And then here, there are two features. There's the prepare data, which is the data prep feature, And if you want to just ingest your data without making changes to it, you can use select table. So for that one, we just selected the data prep feature. So what data prep allows you to do is essentially create calculated columns if you want to, or you can rename your columns, give them new names, or even change the data types themselves. And because this data source is based on a relational database, you also have the option of executing a SQL query. So in this stocks data, what I want to do is be able to see the daily variation as a delta between close and open. So I click on the functions tab, I click on the new column, and then I give that column a name. And then from there, I can create my function. But before I do that, I want to rename my columns so that they're consistent. So, and then from there, I can write my function, which is essentially subtracting market open from close. And I identify my columns with parentheses. And then once I click on apply, you can see the calculated column at the end there. And when you scroll up and down, you can see the values do seem to make sense. The other option you have with QuickSight is that it has inbuilt functions that you can use. And currently, there's conditional functions, there's string functions, numeric functions, or even date functions that you can take advantage of. So for this data set, I want to narrow down a little bit and focus on a particular stock. And this time, maybe it's just Apple. I like Apple products, so I want to see how they're performing. So I supply my select statement, and once I supply the statement, you can see now the data set is all about Apple. So you have the option to save the data set, and then so that you can use it at a later point, and you can give it a new name so that you can identify it from all your existing data sets. So once you save the data set, it's part of your data sets that we saw earlier, and you can either edit it or delete it, or click on it and create a visualization from there. So this is an example of where I just want to use my stocks data as there, because I'm exploring my data. I want to see what patterns I can find. And in this case, I've connected to Redshift. I am using the select table option. And what happens there is that QuickSight gives me an option to either query the data directly from the database, but we recommend using Spice because you get improved performance. According to the Spice indicator, I have enough Spice allocated to my account, and I can then spice my table and then visualize it. OK, let's start by visualizing and analyzing the stock data set. So from this page, that's where you can either create a visual by selecting a suggestion, or you can essentially click on the specific fields that you're interested in, and QuickSight will basically use autograph to determine the appropriate graph for you. So what you're looking at here is actually a graph of market close by trade date for the 16 years of stock data that I ingested. And you can see there's fairly flat economic growth through 2003. And then from there, you can see some steady growth until 2007. But then somewhere around 2007 and 2008, you start to see the housing bubble start to burst. And then between 2008 and 2009, that's when you actually see the Great Recession. And that's when the stock price would fall maybe 400, 700 points a day. And then from there, we see flat economic growth despite the economic stimulus. But then after that, we do see there's a gradual increase. There's a steady increase in the economy. Now, because I want to preserve this analysis, and then I can share it with my colleagues, what I'm going to do is I'm going to capture this in my storyboard. And the way to do that is that I click on capture. And what capture does is that it's going to essentially capture or preserve my analysis as a scene. And I can give my storyboard a unique name. And in this case, just give it a simple name so that I can identify it from other storyboards that I'm going to create. So once I give it a name, I can go back to my visualization and continue looking at the stock market data. And in this case, what I really want to understand is what stocks were responsible for the growth. But before I do that, I can graph by monthly, by month. And then what QuickSight does is that it displays a certain amount of data, but then you also get a slider at the bottom there, and you can slide it to fit as much data as you want in your dashboard. But then here now you can see the market fluctuations a lot better. So, and you can see when the market actually bottomed out, and then it started to increase. You started to see an increase in the economy. So again, I want to preserve this analysis so that I can share it with my colleagues or my team. And I can give it a new name and then add it to my storyboard. So from there, I can continue with my analysis. And when I do my analysis, what I really want to understand is what stocks were responsible for the economic growth. And I can focus on a specific year. And in this case, I want to see what stocks really contributed. And then I focus on June 2013. So from there, I can see that on June 2013, there's really flat. There are no spikes in the economy there based on the stocks that we're looking at. And then if I want to see the actual stocks that were responsible for contributing to the stock price at that point, I can add a ticker. And then this is where QuickSight uses autograph to determine what graph to display. And as you can see, with a slider, you can go back and forth and then to try and visualize. Then again, you can try plotting the graph in different ways, but then we can see there's only one spike there, so the spike is Apple. So we try different plots by week, by day, and then we could try something else. We could try a bar graph, and when I try the bar graph, you get this graph where there's one stock that's actually dominating all others, and everything else is being dwarfed. And then when you hover over it, you find out it's the Berkshire Hathaway stock, which is, at that point, it's $168,000 in market price. So in this case, what I do, because I want to analyze all the other stocks, what I do is that I'll create a filter. And what that filter does is that I can exclude that particular stock, because to me, it's an outlier. I can't really see how the other stocks performed. So once I create my filter to exclude that particular stock, then I can see all the other stocks in a much better way. And again, you can use the slider to fit as much data as possible. Yeah, and then from there, what if I just want to focus on one stock? Say, for example, I talked about Apple before. I can then delete this filter and then create another filter that just focuses on that particular stock. And the way to do it is that in my filter, I'll say, just give me a stock that equals to Apple. Yeah, so once you apply the ticker symbol, then you click on apply, and then you just see the data that's related to Apple. And then from there, what if you want to see how Apple performed over the 12-year period? So you can delete that filter, and then again, delete the date filter as well. And then you can see how Apple has performed over the 16 years that I have the data for, and when it peaked, and when they had a stock split. So as I've been going along with this analysis, I've been capturing all my analysis in the storyboard, and and now I can click on the storyboard and start replaying everything from the beginning. So this is the second one that I captured, and you can see this scene is actually not a static image. It actually has live data, and you can continue to do your analysis. And then we can continue scrolling through all the other scenes to the last one, which is just the upper one that we just looked at. And then you can get out of it when you stop playing the storybook. So now that we've done an analysis of the stocks, the question we're really interested in is, do tweets really affect stock price? So what you see here is a graph. I collected tweets over a 5-day period, and in that 5 days, I was essentially looking at tweets that mentioned different companies. And because the data set was too large, I kind of narrowed it down to just a few of them. And this is over the 5-day period. You can see these like picks for some popular stocks, frequently mentioned companies in Twitter. And not to be surprised, there's a lot of mentions about Twitter. There's mentions about Facebook, and even Apple. And I wanted to explain the anomaly there. So on day one, when I was collecting data, I used the official names for like Amazon, and the official name for Amazon is Amazon.com. So on the first day, all the tweets mentioned Amazon, but not Amazon.com. So I wasn't able to collect any stocks. So that's why, any tweets, and that's why there's a blank there. So to get a better visual of the actual number of tweets in that 5 days, I created a pivot table. And the pivot table actually shows you the numbers of the tweets. And as I mentioned, it was very interesting that even within those 5 days, the number of tweets per company were very consistent. There were no spikes on any particular day. And here's another pivot table where you can actually plot the ticker against the company itself, and then you can see the actual tweets on that day. And here's a heat map that shows the number of tweets distribution. Twitter had the most mentions, and you can see according to that scale. And 13 were the least tweets based on the number of companies that I collected to essentially narrow down my data set. And to see how the tweets were distributed, you can actually use a tree map. And what the tree map does is that it shows you the distribution. And in this case, I plotted against the ticker, but then you can always change that and look at the company itself. So here is where we answer the question. So we've seen tweets for companies. We've seen the popular tweets for Apple and Twitter and Facebook. But then let's answer the question. So this graph shows essentially stock price for those companies we just looked at for that 5-day period. And as you can see, Alphabet has a fairly high stock price. But then when you look at this graph again that we just looked at, you can see, like we mentioned before, tweets are basically distributed along some companies. And then when you put it together, stock price against the number of tweets per company, you can see really there's no correlation. So yeah, so wherever there are peaks with the tweet count, really there's no relationship with the company stock price. And this is just another visual. I selected a horizontal bar graph to show you the same data set. And you can see essentially what I've been describing in the sense that if Alphabet has a high stock price during that 1 week, the tweet count is fairly low. And then for the three most frequently mentioned companies, although the tweet count is high, the stock price is fairly low. And one thing that QuickSight allows you to do is that you can actually flip that bar chart, and then it gives you a different view of the same data. So now it's easier to see which companies had the most mentions in tweets during that 5-day period. So rather than keep scrolling through your analysis, QuickSight gives you the option to create a dashboard. And you can actually grab the edges and drag them and essentially have a dashboard that has some of the visuals that you want to group together. So another thing I wanted to show you is the ability to analyze different data sets. So earlier on, I was looking at stocks, and then again, I looked at tweets. But QuickSight does allow you to actually analyze different data sets within the same analysis, essentially. So and the way to do that is that you can bring in a new data set, and it doesn't matter what kind of data set it is. In this case, I have NASDAQ, which I ingested. I uploaded as a CSV file. And then when you add it to your analysis, you can now actually, when you add it to the analysis, you can go ahead and start analyzing that data set right next to the tweets database. So again, you can create a visual, select a suggestion, and then in this case, I'm trying to show the market variation based on the delta. Yeah, so those are some of the interesting things that QuickSight allows you to do. And this concludes the demo portion. Thank you.
Thanks, Mangeshi. So there's a couple more slides to wrap up. So I think some of the things that we covered both in the presentation and hopefully through the demonstration that Mangeshi put together. So the key points around QuickSight is that it's fast to get started. As a managed service, we provide not only the installation, configuration, patching of not just the visualization, but also the underlying SPICE data set to be able to provide that super fast access. And so as end users or consumers, you just tell us the number of users, the source of the data, the amount of data you optionally want to place in the SPICE engine, and that's it, right? There's no more administrative burden. And I think this is going to be really, really powerful for analysts and our customers, or analysts within our customers. And then, of course, it makes it really easy to explore data sets on AWS. And so by this, we mean if QuickSight is running in the same account as your AWS data source, we automatically detect it with, of course, the appropriate permissions and security overlay that, but make it really easy for AWS data sources. Then, of course, if you have on-premise data sources or data sources outside of AWS, we want to provide the ability to either ingest that into the SPICE engine or to connect to it as well. And then to make it easy to share. So the whole thing about BI is that it's collaborative as well, right? So, and by this I mean we're looking at the QuickSight user interface in the demonstration, but if you can imagine each of those objects that Mangeshi was creating, whether it was a report, a dashboard, a storyboard, those are all accessible through API that you can embed into a third-party application. So you could imagine that if I have a set of data residing in the SPICE engine, and I want to have an interactive chart on an intranet portal or even on a customer-facing portal, of course, we'll have the ability to, save that image in terms of a PDF or some kind of static chart. But what's more interesting is think about embedding that analysis or embedding that report in an application and actually making it interactive from the end user perspective so they can slice and dice the data. And again, we serve up that data through the SPICE engine, which is designed for high concurrency and high throughput to be able to provide that level of assurance of performance. So the UI we looked at, it was just one view of the data, and of course by embedding it, we think is going to be really popular to expand the amount of analysis that can take place through your BI system. And then the final piece is the cost, and I think I've got a little bit of a breakout for pricing. So the important thing to remember on the pricing of QuickSight is that the basic metric is per user per month for sort of the analysts or the people that are creating reports and interacting directly with the system itself. And QuickSight does come in 2 different editions, so standard and enterprise. Standard edition comes with all the basics in terms of the mobile experience, access to all the data sources. What you gain by Enterprise Edition is essentially the option of integrating with your on-premise Active Directory for that user store. Also, the ability to have encryption at rest of the data. And so when we say Spice Engine is in-memory column store, of course, there's still a durable SSD-based backend to Spice. And for compliance reasons, customers want to make sure that the data within Spice is encrypted as well. And so that comes with Enterprise Edition. And the ability to create your own skin on top of the user interface. So changing the colors, the patterns, the logos, the default QuickSight interface are all some of the highlights that come with Enterprise Edition. And so you either pay month by user, or you can prepay for a year, right? So if I prepay for a year in the Standard Edition, it's $9 per user per month. If I prepay for a year in Enterprise Edition, it's $18 per user per month. Then, of course, you can either pay $12 or $24 on the month-to-month basis. And then what's important, we talked about this option to have data repository within Spice. For each user, whether it's Standard or Enterprise Edition, I increase my Spice capacity by 10 gigabytes. So the example is that 10 users, I get 100 gigabytes of capacity in Spice. If I then need to say, well, I need 1 terabyte in Spice, then you just pay the per gigabyte per month charge on top of the base allocation to have your total monthly charge. And if there's questions on that, happy to kind of walk through it. But I think understanding the price model is kind of important to adoption of QuickSight as well. So I think the last thing I'll leave you with, of course, we love to have your feedback in terms of evaluation of today's session. And I think there were a number of hands of individuals in the room today that are already part of our preview. So preview, if you're not familiar, is sort of our way of saying beta, meaning that it's still in testing and development. And if you're interested in participating in the preview, if you just go to aws.amazon.com/QuickSight, you'll be able to sign up for the preview. And generally within a few weeks or a month, we try to get to them as fast as possible, but we try to balance between our development and the preview and onboarding customers as well. So if you're interested in testing it out, please sign up for the preview. And then otherwise, myself and Mangeshi are available for questions afterwards. But thanks for your time today. And I guess we do have a few minutes if anyone has a question for the general audience. Otherwise, you can reach out to us after the session as well. Thanks, everyone.